Hey everyone, so we're going to recap something from not last class, not even this unit, but possibly a few units ago, which is talking about congruency versus similarity. Okay, so I want you to think about congruent versus similar. So let's do a quick recap. How can you determine if two circles are congruent? So knowing what you know about circles, what do you think is the most important part of the circle? Go ahead and respond. What do you think is the most important part of the circle? So the most important part of the circle is actually the radius. So if I wanted to determine if two circles are congruent, I am actually going to determine if the two radius, plural is this, are equal in length. So let me fix this so we could see it a little bit better. So if two circles have the same radius that is equal in length, then they are congruent to each other. How can we determine if two circles are similar? So we just established that the most important part of the circle is the radius. So we want to say something about the radius here. So if two circles are similar, okay, think about similarity. If the two, well, let me type. If the two, radius plural, radii, are proportional in length. So the key word for similar is proportional. You may remember this from when we did like dilations and similarity, and there was something called a scale factor, which was a number that we multiplied to a figure to make it either bigger or smaller. So they are proportional to each other in length. How is the equation of a circle affected by a rigid transformation? Okay, so I want you to take a moment. This was a while ago. This was like way back when. What is a rigid transformation? Go ahead and write your response. What is a rigid transformation? So a rigid transformation is one that preserves the size of the circle, meaning it does not change the size of a circle. So how is the equation of a circle affected by a rigid transformation? So in this case, your rigid transformations would be, and I'm just going to copy this while it looks this way. Your rigid transformations would be things like translations, right? Side to side, up to up movement. Your translations, it would be your rotations, and they would be your reflections. So your equation of a circle is going to be affected by it's going to be affected by adding or subtracting to the circle center. Usually is what's going to happen when we are changing these transformations, okay? So this means that a non-rigid transformation is one that does not preserve the size. So it makes the size bigger or it makes it smaller. So if we're making a circle bigger or smaller, like a dilation, the equation of a circle is going to be, multiplied by a scale factor. Is a number. And that number tells you how much bigger, how much smaller your new circle is going to be. Okay, so we're going to take a look at what that looks like today. So we're going to consider the two circles that we see on the coordinate plane below. I see circle A and I see circle B, and hopefully you see the same. So we already talked about this. What is the key feature of a circle when dealing with transformations? That would be the radius. Sorry for my horrible writing. So the radius tells us where like the transformations go, and also the circle center. The circle center. Evaluate which transformation will map A onto B. So we want to go from A to B. So when we describe the transformations, we're saying what happens to go from A to B. Okay, so the first thing that you should notice is that the circle center is shifting places. So I want to see, and it looks like that's going to be a translation. So it looks like it goes over and up. Okay, and we need to figure out what over and up that's going to be. So it looks like we go over 6, right? This is over 6 and up 1. So a translation, and you can write this a few ways. Over 6 up 1 can be written like this, 6, 1. You may have seen it that way. It also could be written like this, x, y. You may remember this way. Since we moved x over 6, that's plus 6, and since we moved y up 1, so it's that. But that's not the only transformation that we see. The other thing that you should see is that circle A is definitely smaller than circle B. It looks like circle A has a radius of 1, and circle B has a radius of 3. Right? And so if I want to figure out the scale factor is the new shape divided by the original, which I'm going to call the OG. So in this case, the new radius is 3. The old radius is 1. So if, in case it wasn't obvious to you, the scale factor is 3, which means it's dilated by scale factor. I'm just going to abbreviate this because I have horrible writing. Scale factor of 3. So those are the transformations. It looks like it shifted and then it grew, right? And so those would be our transformations. Now, what transformation can be applied to match circle A's radius to that circle B? I got too happy. Here we go. That's what we talked about here. It says use a definition of similarity and transformation to justify that all circles are similar. So remember that with similarity, they're all going to be proportional to each other, right? So what this means is if all circles are similar to each other, all radii are proportional. You'll always be able proportional because it is the only dimension that you're working about. So all circles, no matter what the sizes, are going to be similar to each other because they all have the same number of degrees, which is 360 degrees, because that was another thing that you have to do in similarity. The angles have to be equal to each other. Okay, so hopefully that helps think about the circles. So let's take a look at this a little bit further, and then we're going to take a quick pause so that way this video isn't too long. So consider the two circles in the plane below. What transformations will map A onto itself, and then which transformations will map B onto itself? So we are going to take a look at A onto A and B onto B. What would map them onto itself would be a, hopefully you agree with me, rotation. If I rotate circle A, guess what? It's not going to change, right? If I rotate circle B, it's not going to change. That's my justification. The other one would be a reflection. The reason being, if I reflect circle A across that line, it's still going to look the same. If I reflect circle A across this line, it's still going to look the same across the diameter. So let me just get rid of that because that was ugly. Same thing with B. If I were to reflect it across the diameter, so we can say reflection across any diameter, would keep the circle the same, right? If I reflect it across that, it's going to stay the same. So our reflections are going to keep things exactly the same. Oops. Across diameter. Sorry, y'all, I'm a little bit rusty with this, so I'm trying to get things going for you. Okay, so graph the result of a transformation of circle A using the rule. So this is a translation, and then this is followed by a dilation scale factor of 2. So scale factor of 2, why is this not writing? Scale factor of 2 means that I am getting 2 times bigger. times 2. I'm getting 2 times bigger. Okay, so this -1 plus 1 that I see here, the plus ones that I see is moving x in that direction, and y plus 1 is moving y in that direction. So what that means, from this circle center, I'm moving over 1 and up 1, so my new circle center is right here. Hopefully I can plot that, and that's going to be A prime. That's what this is telling me, A prime. Okay, a dilation of 2. Right now, for circle A, my radius is equal to 1. If I have a scale factor dilation of 2, I am literally multiplying this by the scale factor. So my new radius is 2 times bigger, which is a radius of 2. So from the circle center, my radius goes out 2 in all directions. So it goes out 2, out 2, out 2. You see how it's going out 2 in all directions? And I'm going to try and draw this circle. It's going to look probably like my Pokeball from last class. So approximately that right there answers part B, which is drawing a circle with a translation and a dilation from here. Now, part C, A double prime. So it looks like I'm making another transformation. If A is dilated by a scale factor of 2 centered at the origin instead of centered at point A. So what that's going to do is it's going to come out 2 from the origin. Instead. Okay, I'm not going to go too far in depth into that. Just know that that's a scale factor of 2 from the origin instead. So instead of growing bigger from here, it's going to go bigger from the origin. Okay, so let's take a quick pause and you're going to practice some questions and then we'll pick this back up again.